Good day everybody, this is a beautiful question on number theory. Now why do I say it's beautiful? Just watch this question. So we are expected to find all 3-digit numbers. So when we talk about numbers, we are talking about only integers, right? And more specific, it can be positive or negative, but we will focus on positive integers, such that the number when divided by 6 leaves a remainder 2 when divided by 9 leaves a remainder 5 and divided by 11 leaves a remainder 7. Now you can clearly see why did I say it's a beautiful question. So you are expected to find 3-digit number, right? So such that when the number is divided by 6, when you divide this number by 6, you should produce the remainder as 2. 2 should be the remainder. So when you divide by 9, you should produce a remainder 5. So when you divide by 11, you should produce a remainder 7. And the question is, you are to find all 3-digit numbers. You see that? You need to find all 3-digit number. So just because you are able to find one number, one 3-digit number, it doesn't mean that you have got the solution correct. There can be more than one. So how are you going to handle that? So that's the reason I said this is a beautiful question, and it really expands the thought process of the student or of the programmer or of the coder who is trying to solve this question. Now it is imperative to understand that all these number theory finds greater level of application in cybersecurity, where cryptography is the heart of cybersecurity, right? So if you're good in number theory, you can be assured of a good career. So having given you that insight, I would like you all to spend some time. You can pause the video to work on the solution. What would these numbers be? In other words, how are you going to use basic mathematics to solve such questions? Because the technique that I'm going to apply is just basic mathematics, right? Basics that you have studied. Okay, so with that being said, let me give you the solution. So this is the basic information that I have got. Since I don't have space, I would like to go to the next page. But before I could go to the next page, let me give you the following information. So this is the solution, startup solution, right? So first step, let n be the number which when divided by 6, which when divided by 6 leaves remainder REM as 2. So I'm utilizing REM as 2. So hence the form of n would be, how would n look? Say, since I'm dividing by 6, so 6 is here, let a be some constant. So if this has to be divided by 6, the remainder will be 0. But according to the question, the remainder is 2. So 2 will be the number that would be left out, right? So this is how we represent a number which, when divided by 6, leaves the remainder 2. So by this representation, I can move on to 9, I can move on to 11. So let me move on to the second information. Since n leaves remainder 5 when divided by 9, hence the form of n would be 9 times sum b plus 5, and so on. Since n is divided by 11, the remainder is 7. You can fill it up, right? Divided by 11. So the form of n is going to be 11 times sum c, and the remainder is 7. So this is the first step that we need to give, or we need to write. Now, an observation. What is the observation that you will have to make here, or you will have to take note? Just watch here. 6 negative 2 is 4. 9 negative 5 is 4. 11 negative 7 is 4. So if you can get this step, then the problem is completed. So clearly you can see that there is the quantity 4 is occurring when we perform the difference. So what I'm going to do is, I'm going to add this 4 and subtract this 4 from each of these equations. So this is my equation, this is my equation, this is my equation. So let me go to the next slide. So I would like to write down these numbers. So n is equal to 6 times a plus 2. So as I mentioned to you, I'm going to add 4 and minus 4. Also n is equal to 9 times b plus 5. Add 4, subtract 4. n is equal to 11 times c plus 7. Add 4, subtract 4. So this can be rewritten as n is equal to 2 plus 4, 6. So 6a plus 6 minus 4. This can be rewritten as n is equal to 9 times b plus 9 minus 4. This can be rewritten as 11 times c plus 11 negative 4. Now this can be rewritten further as n is equal to, I take 6 out, so I get a positive 1 minus 4. I take 9 out, so b positive 1 minus 4. I take 11 out, so c positive 1 minus 4. So this is what I've got. Now what I wish to do, I would like to move this 4 to the other side. So n positive 4 is equal to 6 times of a positive 1, n positive 4, 9 times of b positive 1, n positive 4 is equal to 11 times of c positive 1. So this is the way in which the number has to look. Now I got a 6, I got a 9, I got 11. So the objective is to look for a number, right? The first number. So for that, what we need to do, we need to take the LCM of 6, 9 and 11. So let me take the LCM of 6, 9 and 11. I'll start with 2. So because we need to obtain the prime factors. So 2 divides 6 3 times, and 9 and 11. 3 divides here 1 time, 3 times, and 11, and 3 again divides 1 time, and 11. So this is going to be 11, 1, 1, 1. So the LCM is going to be 2 multiplied 3 3s are 9 multiplied 11. 9 times 2 is 99 times 2, which is nothing but 198. So the form of n, therefore n positive 4 should be of the form 198 times m where m takes values as 1, 2, 3, 4 and 5. Now you may be wondering why I did not take 6, because if you were to multiply 198 by 6, 6 8s are 48, 4, 6 9s are 54, 54 plus 4, that's 58, 5, 6 1s are 6, you add 5, you get 11. So this is a 4-digit number, so I need to drop 6. So this is the value of m. Now if I were to take m is equal to 1, we are looking for n. So n positive 4 is equal to 198. So n is equal to 198 minus 4, which is 194. Now this, when divided by 6, leaves the remainder 2. So let me check that out. If 198 divided by 6, 6 3s are 18, it's 194, not 198, 194, right? 194 divided by 6, 6 3s are 18, you bring 1, you bring 14, 6 times 2 is 12, so the remainder is 2. You see that? Now let me check when 194 is divided by 9. 9 2s are 18, you got a 4, and 9 1s are 9, the remainder is 5. So this is exactly what we wanted. And 194 divided by 11, 11 ones are 11, and you get 84, right? So if I had to place 7 there, 77, and you subtract, you get 7. 7 is the remainder here. 7 is the remainder, 5 is the remainder, 2 is the remainder for the first number 194. So this is the first number. Now second number, m is equal to 2, so that means 198 times 2. So 8 2s are 16 1, 9 2s are 18, 19 1, 2 1s are 2, 396. The third number, 8 3s are 24 2, 9 3s are 27, 29 2, 3 1s are 3, 5. The fourth number, 8 4s are 32 3, 36, 39 3, 792. The fifth number, first number, second number, third number, fourth number, fifth number, 8 5s are 44, 45, 49 4 and 9. This is actually n plus 4, right? All of this is n plus 4. So you have to subtract 4 units from each of these numbers. So if you were to do that, this would give me 392, this would give me 590, second number, third number, fourth number, fifth number. So let me just show that to you. 392 when it is divided by 6, 6 times 6 is 36, you get 32, 6 times 5 is 30, remainder is 2. So 392, if you were to divide by 9, let me show that to you. 392 divided by 9, 9 4s are 36, 32, 9 3s are 27, you get 5 remainder. You see that? So this is a beautiful question, and we have got all of the 5 numbers, right? This is second number, third number, fourth number, fifth number, and all because we had applied the concept of number theory. Thank you everybody, enjoy your day.